Have you ever noticed that sharp, almost sweet smell of gasoline at a filling station, or cracked open a can of lighter fluid and wondered what makes them so similar? The answer is a hidden ingredient most people have never heard of: naphtha. It's one of the most important, yet invisible, substances in modern industry. From plastics to fuels, solvents to everyday chemicals, naphtha is everywhere, and without it, our world would look completely different. But what exactly is it? How is it made? And why does it matter so much? Let's uncover the surprising story behind this mysterious chemical backbone of modern life, right here on Story of Things. Naphtha isn't one single chemical the way water is, HO or salt is NaCl. Instead, it's a family of hydrocarbons, a mix of light, alkanes, cyclooctanes, and aromatics. Think of it as a liquid category that lives in the boiling range between gasoline and kerosene. It's not as light as propane or butane, but not as heavy as diesel either. What makes it tricky is that there isn't just one naphtha. Refineries produce different kinds depending on the process and the end use. There's light naphtha, often destined for petrochemical plants, where it becomes the feedstock for plastics and solvents. There's heavy naphtha, better suited for refining into high-octane gasoline. And then there are terms like straight-run naphtha or reformate-based naphtha, all describing different blends that come out of crude oil processing. So when someone mentions naphtha, they're really talking about a versatile pool of hydrocarbons that can be shaped to serve very different purposes, from fueling cars to creating the raw materials for everyday products. To understand naphtha, we need to go back to where it all begins: crude oil. Inside a refinery, crude oil is heated until it vaporizes, then fed into a massive distillation column. Here, something fascinating happens. The different components separate themselves by boiling point. The lightest gases rise to the very top. Liquids like gasoline and naphtha collect in the middle, while heavier fuels like diesel and kerosene settle lower down. At the very bottom, you're left with the thick, tar-like residues. Naphtha lives in that sweet spot between gasoline and kerosene. This fraction, often called straight-run naphtha, can already be used in some ways, but usually, it's just the starting point. On its own, it's not clean or consistent enough for high-performance fuels or advanced chemical production. That's why refineries rarely stop here. Instead, they take this raw naphtha and send it through more specialized processes to reshape, purify, and prepare it for whatever final use is needed. In other words, the distillation tower gives us the rough cut of naphtha, but the real transformation is still to come. Raw naphtha straight from the distillation tower is useful, but it's far from perfect. To unlock its real value, refineries run it through processes designed to literally reshape the molecules. Two of the most important are catalytic reforming and cracking. Catalytic reforming takes the lower octane hydrocarbons in naphtha and rearranges them into high-octane molecules like aromatics and ester. This makes the naphtha far more valuable for gasoline blending and as a feedstock for the chemical industry. Essentially, reforming turns weak fuel into power fuel. Cracking, on the other hand, does the opposite. Instead of rearranging, it breaks down bigger molecules into smaller, lighter ones. Processes like fluid catalytic cracking (FCC) and hydrocracking produce streams that can be blended into the naphtha pool, boosting supply and tailoring the output. The genius of these systems is in their precision. Refineries carefully control temperature, pressure, catalysts, and hydrogen levels to decide what kind of naphtha they'll end up with. Need more aromatics for plastics? Tune it one way. Need high-octane gasoline? Tune it another. By reshaping the molecules, refineries turn naphtha into a flexible building block, able to serve either as fuel for engines or as raw material for the chemical plants that creates everything from plastics to pharmaceuticals. Even after distillation and reshaping, raw naphtha isn't ready for prime time. Straight from the refinery, it often contains unwanted hitchhikers like sulfur, nitrogen, and trace metals. Left unchecked, these impurities don't just lower fuel quality, they can damage expensive refinery equipment and poison the catalysts used in downstream chemical plants. That's where hydrotreating comes in. In this process, naphtha is mixed with hydrogen and passed over a special catalyst under heat and pressure. The impurities are chemically transformed. Sulfur, for example, is stripped out and converted into hydrogen sulfide, which can then be captured and treated separately. The end result is a much cleaner, more stable product. This cleanup step is crucial because it ensures naphtha can safely enter the next stages of its life cycle, whether that's becoming a high-performance gasoline blend or serving as feedstock for plastics and solvents. Without it, the whole system would grind to a halt. In short, refining isn't just about making fuel, it's about precision cleaning, making sure every drop of naphtha meets strict performance and environmental standards. Once naphtha has been cleaned and stabilized, the real fine-tuning begins. Refineries don't just produce one generic version, they custom blend naphtha streams to match very specific industrial needs. Think of it like tailoring a suit. The cut, fit, and fabric all depend on who's going to wear it. Light naphtha, for example, is perfect as a feedstock for petrochemical plants, where it's cracked into ethylene and propylene, the building blocks of plastics, fibers, and countless consumer products. Heavy naphtha, on the other hand, is often sent to catalytic reformers to create high-octane gasoline components or aromatic-rich streams that chemical companies crave. Blending is a balancing act. Refiners measure properties like boiling range, vapor pressure, sulfur levels, and octane to decide which batch goes where. Too light, and it's ideal for chemical cracking. Too heavy, and it might be better suited for high-performance fuel. This constant tweaking makes sure naphtha isn't wasted and that every drop finds its highest value use. In other words, naphtha is never one size fits all. It's a flexible ingredient that can be reshaped into completely different products depending on the needs of the market. If you've never heard of naphtha before, that's only because it works quietly in the background of modern life. Its fingerprints are on everything. When sent to steam crackers, naphtha is broken into ethylene and propylene, the raw materials behind plastics, synthetic rubber, and countless everyday products. Your phone case, packaging, clothes made from polyester, all trace back to this invisible fuel. But that's not all. Certain grades of naphtha become lighter fluid, solvents for cleaning, or diluents used to thin out heavy crude oil so it can flow through pipelines. In the energy world, naphtha is blended into gasoline to boost performance, while in the industrial world, it helps power chemical reactions that create medicines, fertilizers, and coatings. It's this flexibility that makes naphtha so important. Refineries treat it like a Swiss Army knife. One stream can end up fueling your car, while another may transform into the plastic in your laptop or the chemicals in your shampoo. The scale of its reach is staggering. It's the quiet foundation of modern manufacturing and fuels. For all its importance, naphtha isn't without risks. It's highly flammable, and its vapors can pose health hazards if inhaled. That's why handling and storage are tightly regulated in refineries and shipping facilities. Protective equipment, sealed containers, and strict safety standards are non-negotiable when dealing with it. Then there's the environmental side. Naphtha production is tied directly to crude oil refining, meaning its footprint is linked to fossil fuels. As the world shifts toward cleaner energy and lower emissions, refiners face mounting pressure to rethink how much naphtha they produce and what it's used for. Some are exploring bio-based or alternative feedstocks, while others are improving efficiency to minimize waste and pollution. But here's the catch. Even as industries talk about decarbonization, demand for plastics, solvents, and petrochemicals keeps climbing. And for now, naphtha remains one of the most reliable bridges between crude oil and the modern materials we rely on every day. Its future may look different, but its role in shaping everyday life isn't disappearing anytime soon. So, what exactly is naphtha? It's not just a single product, but a family of hydrocarbon mixtures that sit right at the crossroads of fuels and chemicals. From crude oil distillation to reforming, cracking, and hydrotreating, its journey through the refinery turns it into one of the most versatile tools in modern industry. One grade might become the backbone of plastics. Another might boost the performance of gasoline, while lighter cuts serve as solvents or lighter fluid. Even if most people never see it, naphtha quietly supports the energy we use, the products we buy, and the infrastructure we depend on every day. It's powerful, it's practical, and it's also a reminder that even the smallest streams inside a refinery can ripple across the global economy. And as the world pushes toward cleaner energy and more sustainable practices, the story of naphtha isn't ending, it's evolving. Whether it's replaced, reshaped, or reinvented, This invisible workhorse of modern chemistry will always hold a place in the history of how we power, build, and innovate. Thanks for watching. Don't forget to like, subscribe, and stay tuned for more surprising stories behind the simple things that shape our lives.